Hello everyone, my name is David Rajendra and my matrix number will be 25DDT19F1184. Today I'm going to present my Pbt presentation set A. So the topic is about topic 4.3, complete a prototype testing plan to verify a network design. The packet tracer on my right will be the Pbt packet tracer that have been done previously. So for the presentation today, I will be going through three objectives. Part 1, interpret the result of EIGRP routing. Part 2, discuss and share opinion about summarization in EIGRP. And also part 3 about discuss and share opinion about the wasted IP addresses in this POM. So the first will be part 1, interpret the result of EIGRP routing. Based on the output student get from assessment problem-based tasks, output from R1, output from R2, and output from R3, and output from R4. First, I will be starting from R2. So here we can see the summarized route 192.168.9.0 and also 192.168.10 for the EIGRP. And next will be show IP protocols. In show IP protocols, we can see the routing for networks 1 and also the previously assigned EIGRP or bus number 10. And the gateway will be next of IP address 192.168.8.1. The next comment will be show IP EIGRP protocols. Neighbors. So the neighbor will be 192.168.8.1, and the next comment will be EIGRP topology. So in our topology, we can see there will be 4 passive networks. So the next will be R3. Show IP protocols. And in our R3, we can see there will be one routing for network 192.168.9.0 and one gateway 9.1 with the EIGRP number 10. In our route, we can see there is 3 routes 8.0, 9.0 and also 10.0. For the neighbor, we can see the next of IP address 192.168.9.1 and the last one will be topology. There will be 4 passive networks. And the next will be R4. For the show IP route, we can see there will be 2 connected interfaces and also 3 EIGRP. The next will be show IP protocols. For the IP protocols, you can see 192.168.10 and also the gateway 10.1, which will be the next of IP address, and the EIGRP 10. And for the topology, there will be also 4 passive networks 8, 9, 10.0 and 10.128. And for the neighbor, will be also the same, one neighbor and the next of IP address. And the fourth one will be R1. In our R1, we can see there will be 1, 2, 3, 4, and 5, 6 EIGRP routes, which are being summarized in the show IP protocol. In show IP protocols, we can see 3 networks and 3 gateways together. Also, we can see the automatic address summarization with 3 networks with the /24 subnet, and we can also see the EIGRP 10 here. Next will be show IP, EIGRP neighbors. So for the R1, we can see there will be three neighbors, R2, R3, and R4. There will be three IP addresses. And finally, the topology. In our R1, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9 passive networks. So that's for the part 1. And now for the part 2, discuss and share opinion about summarization in EIGRP. Should or should not summarization enable in this design and why? Would root summarization occur in a non-hierarchical design and why? So for the part 2, question 1, we should enable the root summarization in this design because root summarization decreases the number of entries in a routing update and reduces the number of entries in local routing table. So here we can see in our routing table, sorry, R1. So in our R1, we can see the routing table is summarized. The subnet 192.168.0 is summary, and the both subnet 192.168.0, 192.168.8.128, they both will be traveling through the same interface S000, and also same for the other networks. Root summarization allows a router to group networks and announce them as a large group through a single summarized route. It also reduces the use of bandwidth for routing updates and speeds up searches in routing tables. EIGRP recognizes the subnets as a single class A, B, or C network and creates only one entry in a routing table for summarized route. As a result, all traffic designed destined for subnets travels along that route. So in our one, we can see the subnet 192.168.0/24. Even though we configured the /25 previously, the auto summary command summarized the network into /24 so that the single network travels through the same path, serial 000. And for the next question, would root summarization occurred in a non-hierarchical design and why? So the answer will be no, because root summarization is usually effective with hierarchical network design. Non-hierarchical design is a small network design. When root summarization is implemented, the network will be classifying subnets as a single class A, class B, or class C network. Thus, it makes the routers to search for routes. Without implementing root summarization in non-hierarchical design, can reduce the packet size and leaving more bandwidth for data transfer. So basically, the non-hierarchical designs are small network designs, which are designed to use between the LAN and WAN networks. It not includes the distributed or core layers. And that will be the end of part 2. Now for the part 3, discuss and share opinion about the wasted IP addresses in the design. How many IP addresses in this design are wasted? Support your answer with a calculation. Okay, and for this one, we can see the IP subnet calculator. The IP address network will be 192.168.0, and the usable IPOs will be from 1 to 11.254. So the total IP addresses, so the total number of hosts will be 1024, and the number of usable hosts will be only 1022 in our design. So basically, we have used six subnets starting from 0 to 5. And this will be the networks we have been currently using in our design for the total of 6 subnets. So in our topology, also the network, we have given the 1022 usable host, and we are only using 765 only. So the remaining will be 765. We can see the remaining will be 257, and that can be considered as wasted IP addresses, 257. And the next question, what change should be made to this IP addressing scheme to be more efficient? Suggest a new subnet assignment and fill in the table below. So here in our table, I've already prepared with the previously used 6 subnets, and since we are having only the 257 subnets available, so we can divide the subnets into two. So there'll be approximately 128, which can be used as the /25 IP address. So I've been created the two new subnets with /25 IP address. So in our two new subnets, every one of them will be having 120 IP addresses. So for the two new subnets, we have been using the 255 IP addresses, and previously we have been using 3. So now we'll be using together with this one, so that will be 4. And the total IP address we are being used is 1020. So previously there will be 1022 hosts, usable hosts in our network 192.168.8.0/22. So now in our new subnet assignment, we can see that the remaining will be only 2 IP addresses. So the new subnet assignment is much more preferable than the previous subnet assignment. The the number of IP addresses are being wasted is now reduced to 2. And that will be the end of my PBT presentation, Sati. Thank you for watching.